In this experiment, we are going to implement linear regression from scratch using Python. For the first step, in this step we import the required libraries: pandas for data manipulation, numpy for numerical computations, matplotlib for plotting graphs. Then we read the dataset using pd.read csv and store it inside a data frame called df. For the second cell, in this step, we perform data cleaning. Real world data sets often contains missing values. So we calculate the mean of the alcohol column and replace missing values using the fill now function. This process is called imputation, where missing values are replaced with the average value of the column. For the third cell, X represent the independent variable which is alcohol content. Y represent the dependent variable which is wine quality. For the fourth cell, now we calculate the coefficients of the regression line. First, we compute mean of X, mean of Y, number of observations. Then use the mathematical formulas. Um, then for the next one, we are predicting Y using the regression equation b0 plus b1h. We calculate the predicted values called Y predict. These values represent the predicted wine quality based on alcohol content. Calculate SSE. In this step, we compute SSE, sum of squared errors. SSE measures how far predicted values are from the actual values. This formula is summation of y minus y prediction power 2. And for the next one, we are calculating RMSE, root mean square value error. So next, RMSE is the square root of SSE divided by the number of observations. For the next cell, now we compute R square, also called coefficients of determinations. R square measures how well the regression line fits the data. Um, for the plot graph, we visualize the results. Scatter plot of actual data points, regression line showing predictions. The red dot represent actual data points. The blue line represents the regression line. For the predict y for new X, finally we test our model. We give a new input value for alcohol content. For example, X is equal to 3. Using the regression equation, we calculate the predicted wine quantity. For multiple linear regression, in this experiment we implement multiple linear regression. Unlike simple linear regression, this model uses more than one independent variable, b0 plus b1 h1 plus b2 h2. First, we are reading the CSV file. Then we are data cleaning it, and we are choosing the variables. H1 is equal to alcohol, H2 is equal to sulfate, Y is equal to wine quality. We calculate the regression coefficient. B0 is equal to intercept, B1 is equal to coefficient for H1, B2 is equal to coefficient for H2. Step 5, calculate predictions. We compute predicted values using equations. Y predicted is equal to B0 plus B1 H1 plus B2 H2. For this step 6, we compute SSE, which measures the total square differences between actual and predicted values. For root mean square error, now we compute RMSE to measure the average prediction error. For the R square, we calculate R square to measure the goodness of fit. Higher R square means better model performance. Finally, we test the model by giving new values. H1 is equal to 6.5, H2 is equal to 4.5. The model predicts the wine quality based on these values. Then we are seeing logistic regression. In this experiment, we implement logistic regression. It predicts probabilities using sigmoid function. First, we are reading the data, then pre-processing it, mean imputation, label encoding. Then we are selecting variables. Next, we select the independent variables such as fixed acidity, volatile acidity, citric acid, residual sugar. Then for the fourth, in logistic regression, we minimize the cost function using gradient descent. Gradient descent repeatedly updates model weights to reduce prediction error. This process continues until the model converges. We plot iterations versus cost. This graph shows how the cost decreases during the training. If decreases steadily, it means the model is learning properly. Calculate accuracy. Finally, we calculate the accuracy of the model. Accuracy means measures the percentage of correctly predicted values. Formula: accuracy is equal to correct predictions divided by total predictions. Higher accuracy means indicates better classification for performance.